Today we'll try to understand over here find S algorithm. Find S algorithm basically is used in order to find the maximally specific hypothesis in a given hypothesis space. So we'll try to understand this with the help of an example, and for which I will consider this as a data set wherein you will see there are 7 attributes given in this particular data set. The first 6 attributes you can call them as input variables, and the last one you can call it as a target variable, and so on. This target variable is binary classified, and then if you go with these attributes over here, you have an attribute called weather, an attribute called temperature, humidity, wind, water, and forecast. This weather attribute can take the value as sunny or it can take a value as rainy. Similarly, temperature can take a value as warm or cold. Humidity can take a value as normal or high. Wind is going to take only one value, which is strong. Similarly, water can take a value as warm and cool. Forecast can take a value as same or change, and so on. We need to remember one thing over here. Find S algorithm is going to work only on the positive instances over there. So out of these 4 examples which are given to us, there are 3 positive instances over here and 1 is a negative instance over there. So we'll try to understand find S algorithm in order to find maximally specific hypothesis. So the first step over here involves initializing the hypothesis with the most specific hypothesis over there, which means I'm going to initialize H0 as null, 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 and so on. So where we consider this null as most specific value over there. I have used here 6 nulls because we got 6 input variables. So then what we need to do over here is we need to compare the values which are given in the hypothesis with the values given in the example. And if the values are going to match, then we are going to perform nothing. Otherwise, the value in the hypothesis is to be replaced with the more general value over there, which means now I will compare the values of H0 with the values of X1. So before that, I'll try to explain you this with the help of 4 statements over there. So this is what we are trying to say over there. For each positive training instance in X, we are going to consider only the positive training instances over there. When there is a positive training instance, this is an instance, this is an instance, and so on. Once there is a positive training instance, we are going to take the value of an attribute in H, that is this value, and then this value will be compared with the values given in the example. So this null will be compared with this value, this null will be compared with this value, and so on. If there is a match, we do nothing. But if there is no match, we are going to replace AI. AI over here, you mean this is A1, this is A2, A3, A4, A5, A6, and so on. So these values we are going to replace in H by the next more general constraint that is satisfied by X. So what it means for us, we'll try to understand this. So I'll take this particular diagram once again, that is data set once again, because we are going to work on this data set. I'll try to paste it over here. And then what I'm going to do is I'm going to write your H0, as I said, it is a specific hypothesis we are going to consider over there. Okay, and this specific hypothesis are the values over there you are trying to compare with the values in the example. So now H0 is considered to be the most specific hypothesis. So as per this statement which we have written over here, we are supposed to take the positive instance and the attributes in that. So what you are going to do over here, you take the first example out of these four examples, which means you are going to take this one, and then you try to write the values of that here. It is sunny, warm. I'm just copying normal, strong, warm, same. So what is that I'm going to do now? I have an hypothesis, more specific, and I have an example. So then I'm going to construct the next hypothesis, and then how is that I'm going to create this? I am going to compare the values in the example with the values of the attributes present in the hypothesis. If they are going to match, then I'm going to do nothing. So if you want this, I can show you with the help of a flowchart. So I'll just try to copy this flowchart so you can see over here. So what is that we are trying to say over there? We are trying to say that we'll first initialize the hypothesis with the most specific one, and then we'll try to take the positive instances, and we'll try to compare the values in each of the attribute. Like this value will be compared with this. If it is matching, we are going to do nothing. Otherwise, we are going to replace with next more general value over there, and so on. Okay. So how is that we are going to do this now? So then I'm going to construct here the next step. I will consider, or I will construct H1, and then H1 I am going to generate by comparing this value of H0 with X1, the first example. If they are matching, well and good. Otherwise, you are trying to, or you will try to take the more general value over there, and so on. So I'll compare this null with sunny. So out of this, it is not matching, so I'm going to replace with the more general, which is a specific value over here, and that is sunny. Likewise, I'm going to compare the second null with warm, and I'm going to replace with warm. Then I'm going to replace with normal. Then I'm going to replace with strong. Then I'm going to replace with warm, and then I'm going to replace with same. So this is how you construct your hypothesis over there. Now, step 2 over there. What is that you are going to do? In step 2, you will take the second example from the given data set and then try to compare with the H1 hypothesis over there. So you take second example over there, x2 is equal to, just try to copy the values over here, sunny, warm, high. You can write that, sunny, warm, high, strong. Then you take warm and same, warm and same. Now what all you need to do is, you are supposed to compare the values of H1 with the values of X2. Okay, and then you try to construct H2. So H2 will be equal to, now I'll compare sunny with sunny. It is match, so I just copy the same value over here. Warm with warm I'll compare. It is matching, so I'll do nothing, no replacement. Now here you have normal and here you have high. So because there is no match over here, I'm going to replace with general value over there. Okay, so which means I'm going to replace this with a question mark, where question mark can take any value over there. And then strong I'll compare with strong because they are matching. And then warm I'm going to compare with warm as they are matching. I'll write the same, and same is matching with same, so I'll write here. So that is how you are going to construct the next hypothesis, which is H2 and so on. Now in the next step, what is that you are going to do? Step 3. What are you going to do in step 3? You are going to consider the third example from the given data set. Third example, if you consider over here, it is a negative hypothesis over there, that is negative instance over there, or instance with the negative value over there. So as we know, find S algorithm, we are going to use only the positive instances. So what we are going to do is, we are going to just ignore this and so on. So when you ignore this, what happens is your H3 will be now equal to H2 only. So I just try to copy these values over here. Sorry, I'll paste it over here like this. Fine. Then I'm going to consider in the next step, I'm now going to consider the values of H3 with example 4. Example 4 I can consider because it is a positive instance over there. So I'm going to consider these values from example 4. So I'll say x4 is equal to sunny, comma warm, comma high, comma strong. I'm taking it from the fourth example, this one. And then you have a cool over there, followed by change and so on. So these are the values that you have in x4. So now I'm going to consider our construct. I'm going to get the values for h4 over there and so on. So how you get that? h4 is equal to you have to compare the values of your h3 with the value that is present in x4. Okay, so how you are going to do this? So you will compare sunny with sunny. It is matching, so you will write sunny over there. Warm you are going to compare with warm, so you will write the same value over there. And then question mark you will compare with high. The more general value over here is question mark, so I'm going to put question mark over there. And strong is matching with strong, so I'll just replace with strong over there. Warm and cool, they are not matching with each other, so I am supposed to replace this with a question mark. Same and change is not going to match with each other, so I am going to replace with a question mark. So then this I am going to consider as the most specific hypothesis. And this is how you can find the most specific hypothesis using an algorithm called find-S algorithm. So I'm going to repeat this once again. So we are going to work on a data set which is given over here, having 7 attributes. 6 of them you can call it as the input variables, and the last one you can call it as your target variable and so on. Your target variable is binary classified, wherein you have the values as yes and no over there. This find-S algorithm we are going to make use of only for positive instances and not for the negative instances over there. Now in this data set, we are given with 4 examples over there, and then we are going to find maximally specific hypothesis in this. So the first step over there is we are supposed to create an hypothesis by considering the most specific values over there. So when you talk about most specific values, you can write them as null values over there and so on. And then we are going to compare these values of this particular hypothesis with the first example. And if the values of this first example matches with these values in your hypothesis, then you are going to perform nothing. Otherwise, you are going to replace the value with more general value over there and so on. Like H0 values will be compared with X1. Null do not match with sunny, so I'm going to write it as a more general value over there, which is sunny. Null with warm, I'm going to write warm. Null with normal, I'm going to write it as normal. Null with strong do not match, so I will write it with the more general value, which is strong. Null with warm, I'll write it as warm. Null with same, I'll write it as same. So that is how I will get H1 over there. Now, the next step over there, the second step is to compare the values in this particular hypothesis with the second example over there, provided the second example is a positive instance, because we said find-S is going to work only on the positive instances and not on the negative instances over there. So H1 we are going to now compare with the values present in our second example. So the values in second example are sunny, warm, high, strong, warm, and same. So these are the values in second example, X2. Now compare with this. So sunny matches with sunny. So you will write when it matches, you are supposed to perform nothing. Warm matches with warm. So you are going to write the same value. But here, normal do not match with high. So you are going to replace with a general value over there, which is question mark. Strong matches with strong, so you will write as it is. Warm matches with warm, so you will write as it is. Same matches with same, so you will write as it is over there. So that is your second step. Now coming to step 3, you are going to take the third example. But as you know, the third example is not a positive instance, it is a negative instance. So you are just going to ignore the third example. You are not going to consider it. So when you ignore that, what happens is your H3 now becomes equals to H2 only. So then what we are going to do, the last step, which is step 4, you are going to compare the values of H3 with the values in X4. So the values of X4, sunny, warm, high, strong, cool, and change. Do write that and try to compare the values of X4 with H3. So when you do so, what you get is sunny. When you compare with sunny, you get sunny. Sunny, that is warm. When you compare with warm, it is a match, so no change. Question mark when you compare with high, there is no match, so you will write the general value there. Strong compared with strong, it goes in the same way. Warm when you compare with cool, they are not matching, so you are going to replace with question mark. Similarly, same is not going to match with change, so you are going to replace with question mark, and so on. So you can see now this is the most specific, maximally specific hypothesis that you have found out. You have found this by making use of this particular algorithm called find S algorithm. So if you like this particular video, please share this video with your friends and then try to subscribe to my channel and then press the like button over there. Thank you.